We're given this graph here of some function g of x, and we're asked a bunch of questions about it. First one is, what's the limit as x approaches 1? So as you get closer and closer to 1, from the left, from the right, both of those parts are coming towards this hole in the graph, and it's at a value of 3. So again, a limit is what a function looks like it equals, not necessarily what it does equal. We get 3 for that. What is g of 1? What does the function equal at 1? Well, according to this, for whatever reason, the dot's down here at a value of 1. What does the function equal at 2? Well, if you go to 2 and you go up to the function, it looks like we're at a value of 2 right there. Okay. What is g prime at 2? How is the function changing at 2? If we were to put a tangent line at 2, we'd see it's pretty horizontal. Looks like our derivative would be 0. The slope of that tangent line would be 0. What is the limit of this function as x approaches 3? As I come from the left side, I'm heading to this value. If I come from the right side, I'm heading to a different value. I have a disagreement, right? We have what's called a jump discontinuity. Therefore, that limit does not exist. But what if I just wanted from the left side? Forget the whole limit. What if I just came at 3 from the left side? If we were to come from the left side, we'd be heading up to here, which is up at a value of 4. What is g prime of 4? If I go to 4 and here's the function, if I was to think about a tangent line, the tangent line would just be parallel with this, right? It would be right on top of it. So the derivative at 4 is the slope of this line. So if I think about it, we're at 2, we're going down to -1, so that's down 3, and over 2, we'd have a slope of -3/2 for that. Okay. Is g prime of 5 greater than 0? If you go to 5, we have a sharp turn there, right? Because we have a sharp turn, we don't have a derivative. So it's kind of a sneaky question. Is it greater than 0? No. G prime of 5 is undefined. It's not less than, not greater than, it's not nothing, because you have the sharp turn there. The next one says, what's the limit as of g of x minus g of 6 over x minus 6? This is a recognition kind of problem. We have to see this as the definition of a derivative. And so what it's really asking you is, what's the derivative of g at 6? So if you go to 6 and you look, pretty horizontal at that point, I would say the derivative is 0. Again, how did we get that? We recognize that this represents the derivative of g at 6, and then that's how we go. Where is g not continuous? Where do we have a break in the graph, some type of disruption? So as you look, we have a hole in the graph at 1, we have a break, jump discontinuity at 3, and then that's about it. So we would say g is not continuous at x equal 1 and at 3. Again, 1 is a hole in the graph and 3 is a jump discontinuity. Now, where is g not differentiable? So anywhere that it's not continuous, it's not going to be differentiable. So we have a problem at 1, we have a problem at 3. But we have another problem at 5. We already talked about it, that because of this sharp turn, we don't have a derivative at 5 either. The graph is continuous there. You can draw that without leaving your pen or pencil off the paper, but we're not going to be able to take the derivative at that spot. All right.